computing DFT for one analog or continuous function which is given. So let me first draw. We have a function which is a continuous function. So we have t, y-axis is f of t, something of this sort. So first we need to convert this f of t to f of x. So let us do it first. So this side would be x and f of x. So if this was, so now the first thing is to sample it. So it's given that, it is sampled at, let us take that as delta x only, and our starting point as x naught. So let us take first point. And here when we are looking at this discretization of the signal, then, whenever it is going beyond 0.5, you take it as an upper point. Whenever it is staying below that, you take that as a lower point. So here, actually how accurately your function is depicted after sampling will depend upon the spatial resolution that you have taken. So this is my 0, x naught. This will be x naught plus del x. This would be x naught plus 2 delta x, x naught plus 3 delta x, and so on. So on the left hand side, we have magnitude 1, 2, 3, and 4. So now we need to write the equation. So here our f of x is f of x naught plus x times delta x. So now tell me what will happen for first position f of 0, f of x naught, which is 1. So now this 1 will come here. 2, 3. So this is my first point. Next will be f of x naught plus delta x. So it will be 2. So next is 2. We have, this is 1, and more 2 points will be 2 and 3. Let me write one sample for 2. F of 2 would be f of x naught plus 2 times delta x. So f of 2 times delta x is coming here, and this is 4. So we will have, and next is also 4. Now we need to calculate its DFT. So in order to calculate DFT, let us first write our equation. And we will be writing equation only in one dimensional right now, because our function is also 1D. So that will be, for now I'll erase these two equations as we don't need it. Okay. So now f of u is, that is transformed function in Fourier domain, is summation of x equals 0 going to m minus 1. Here also you get 1 by m, that is total number of samples, f of x, and then exponential of minus j 2 pi. Here I'm writing in a different color, so we see x by m. Please do it with me, so that, and because in this u and x are varying at the same time, so sometimes it really creates confusion. So here you have to see that for calculating every f of u. Now what is f of u? Here f of u is our transformed function in Fourier domain. So u0 means 0 frequency, 1, 2. So this will also be coordinate in a Fourier domain. But when we are calculating f of 0, let's say, that u equal to 0 will also involve all the values of x. going from 0 to m minus 1. So here, how many number of samples we are having? What is our m here? In this situation, our m is 4. Hence, it's going from x equals 0, 1, 2, and 3. We have 4 values in total. So let us calculate our first value. So for this situation, I can write my u will also be having how many values? 0, 1, 2, 3. And your x is also 0, 1, 2, 3. So let's calculate first our DC point f of 0. So our DC point f of 0 would be summation of, 1 by 4 summation of x 0 to m minus 1, that is 3, f of x. And because now in this situation we are calculating it for 0, here we can straight away write u equal to 0. Even though x will vary, once u is 0, everything will become 0. So here we can straight away write exponent of 0. That will make everything 0. So what we will have? 1 by 4 f of x. So now x is varying. What is f of 0? Magnitude for f of 0 is how much? 1 plus f of 2 is 2. Okay. And then rest 2 are 4 plus 4. So our answer will be, so it's 2 plus 1 plus 4 plus 4. Hence our DC point is coming out to be 11 by 4. So now sometimes you might be given a function directly in continuous domain with the discrete intervals defined, and you are asked to calculate the value at a DC point. So no need for doing any of this calculation. You can straight away add up all the values of the function and divide it by the total number of samples. Now let us go ahead to the complicated part for calculating f of 1. What will be f of 1? F of 1 would be 1 by 4 summation of x from 0 to 3 and f of x. And now my exponent will not be simply 1. Now we have to write exponent of minus j 2 pi. And now our u is 1. So that I can straight away write 1 multiplied to x by 4. Okay. So this now we need to expand. Let's do it. So now it will be 1 by 4. And first let us substitute x equal to 0. So substituting x equal to 0, it will become f of 0 exponent of 0, because here my x will become 0. Next term would be f of 1 and exponent of, when we are going to substitute in place of x also 1. So it will be minus, here we can also cancel this out, this 2. So it will become 2 here. So it will become easier for us to write. So it will be minus of j, and our x is also 1 here. So it will become j pi by 2 plus f of 2 exponent of minus. Now instead of x, now there will be 2. So this 2 will also be cancelled out. It will be minus j pi. After that, then next term would be f of 3, that is our last term. F of 3 exponent of minus, now x is 3, so 3j pi by 2. Now let us substitute value of f of 0, f1, f2 also. So it will now become 1 by 4. F of 0 is 1, And so it will be 1 e to the power 0 plus f of 1 is 2. So 2 e to the power minus j pi by 2 plus f of 2 is 4. 4 times e to the power minus j pi plus again 4 e to the power minus 3j pi by 2. Now let us expand it. Now we have to expand it further. So now we are going to use Euler's expansion. Now we want e to the power minus j theta can be written as cos of theta minus j sin theta. When it is plus j theta, then you write cos of theta plus j sin theta. When you have negative sign, the intermediate sign also becomes minus. Okay. So the expansion of e to the power minus j theta is cos theta minus j sin theta. So let us substitute it. So with this, it will become 1 by 4. E to the power 0 is 1. So this will become 1 plus it will become 2 cos of pi by 2 minus j sin pi by 2. Next term will be plus 4 cos of pi minus j sin of 1. Then next term is plus last term, right? Yes. 4 cos of 3 pi by 2 minus j times sine of 3 pi by 2. Now we can exclude whatever is 0. So automatically we can remove. So cos pi by 2 is 0. So that we can remove. Then sine 180 is also 0. So that way you can get rid of this also. And so is cos of 3 pi by 2. So let us write it again. It will become 1 by 4. 1 plus minus 2j sine 90. So sine 90 is 1. So minus 2j plus this is gone. So cos of pi is minus 1. So this will also be minus only. Minus 4. And here it will be 4 times minus j sine of 270. So sine of 270 is again minus 1. So it will become plus 4j. So we can write plus 4j equal to 1 by 4 minus 3 plus 2j. And this is our which term? F of 1. Okay. Similarly, you have to calculate f of 2 and f of 3. Now, let us look at what we will get if we want to go back from our Fourier term to the spatial term. So similarly, I will only write the answers here. Similarly, f of 2 will come out to be 1 by 4 minus 1 and f of 3 would be 1 by 4 minus 3 minus 2j. Now, in order to calculate reverse, that is the inverse transform, we will need all these quantities. So now, let us try and compute the inverse of it. So now we want to calculate small f of 0 from here. So let's see what is the equation. Calculating IDFT, that is inverse discrete Fourier transform. So what is our equation again? Now our output will be small f. So let me write the equation again. F of x is given by Now, since we have taken 1 by m in the forward transform, for inverse we will not take. If you have not taken over there, then here you need to include that multiplication of 1 by m. So now my variation will be from u 0 to m minus 1 f of u exponential of, now instead of negative it will be now positive, j 2 pi u x by m, where again our u is going from 0, 1, 2 to m minus 1. Now let us calculate only f of 0, because we know our f of 0 is how much? 1. Let's calculate. So we will have f of 0 equals, now we will need all the values of u in order to calculate it. So it will be 0 to 3 and it will be f of u, and now because our x is 0, exponent again becomes 0. So it will become, we have to add all the values. So for this, we will also need f of 0. What was our f of 0? F of 0 was 11 by 4. So let us write. So I will just take 1 by 4 as common. So 11, second term is minus 3 plus 2j. Third term is minus 1. And fourth term is minus 3 plus 2j. Let's see if it gives. 11 minus 3 plus 2j minus 1 minus 3 minus 2j. So this 2j will cancel out. And here you have 3, 3, 6, 7. 11 minus 7, 4. And you will have 1 by 4 into 4. Answer is 1. Hence, you have got f of 0 as 1, which we started with. So if you see, our f of 0 was, our f of 0 was 1. Okay. So similarly, if you substitute, you will get other values of f of x also. So only complication will happen that now your u will become non-zero, hence all those exponential terms will come, and now you will use that Euler expansion, e to the power j theta cos theta plus j sin theta, and you can do. Okay.